Hello, hello, hello. We're today we're I'm actually in Granite Bay today with the Field Fest coaching. So we got one more quiz, and the quiz is on satellite. So I want to break it down for you. What we're going to do today in class is um, the satellites has three AP videos: 6.1, 6.2, and 6.3. And if you look right here, they are circular orbits versus elliptical orbits, uh, and then escape velocity 1, 2, 3, 1, 2, 3. And so when you take these, I actually have done notes for you that go along with those videos. So this is 6.6.1. The basic idea here is it's elliptical orbit in its review from before, where we find the velocity of a satellite. And then we also relate it to energy. Now, be careful if you're only talking about the satellite and not by itself. It's different than if you talk about the satellite and the planet in the middle. So it's remember we got a little systems approach here. So you got to careful with the systems. The second video is about elliptical orbits, and so very often they'll be in ellipse, and it's a little bit more complex. But if you look at the whole Kepler's law thing that we've done in the past, the farther away it gets, the slower it is, and the closer it is, the faster it is. That's kind of one of the big main parts of it. But there's also a conservation and momentum part of it as well, and there's an energy part of it as well. The little graph here shows, oh, this is just the graph of the energy of the satellite, and this is the graph of the energy and the satellite and the planet. And it's explained in the video. So watch the video. The videos are not very long, 6, 7 minutes long. I didn't say that. Let's see. And then the third video is called escape velocity. And escape velocity is if you launch a rocket and shut the rockets down, will it come back? Right? That's not escape velocity. That's going to put it into elliptical orbit. If it's going fast enough, there goes the bell. If it's going fast enough, it will actually escape and go off into space. And we've talked about gravitational energy in the past, so this brings back gravitational energy. I'm not talking about gravitational energy on Earth. I'm talking about gravitational energy of satellites and rockets that are far away, where zero is set at infinity, right? That's U capital G. It's that little equation right there. So watch those videos and try to do the quiz. Okay. If you need extra help on the quiz, there's actually two quick videos by an outside person. I just thought they were quick, good videos that talked about elliptical orbits. So if you need a little extra help, watch that one or the other one I've linked. There's also a little note here in the middle that says see spreadsheet. So there is a comparison, which they all wrap together. Some people want to know, like, how fast is it going at each point? Well, we really usually only ask the closest and the farthest point because they're the easiest ones. So the closest and the farthest point are actually have this kind of perpendicular motion vector, and the other ones don't have a perpendicular motion vector, so they're much harder. But if you're going down the rabbit hole of could I figure out how fast it goes at each point, which might be a question here or there that they might ask you, but those are harder. So that's what this is about. This is saying, okay, let's look at that. Anyway, that's Kepler's law. There's one more thing actually I didn't mention is two more things. Is today's warm up is about it's a review of the last Sparky quiz, and we should be done with all our Sparky quizzes now, hopefully. It's just a lot of students do kind of get mixed up. Like, is the clay that's incoming that's going to hit? Is it in a rotational system? And really, that just the wording. So listen to the wording. If the clay is outside the system, then it's an impulse. If a person runs up and jumps onto a merry-go-round and they're outside the system, then it's an impulse. If it's inside the system, then it's a collision. And we have the law of conservation of momentum. So it just depends on the wording of system, outside the system or inside the system. The last thing is on the next page of the agenda. Two things is that if this is unbalanced, it might swing, right? And actually, it looks backwards in my. That's weird. So that's why it might swing, but it's not going to swing at a constant acceleration. If something falls, it falls at a constant acceleration. But as it swings, gravity is only straight down. And so torque changes because torque is when the object is flat like this, flat like this, the gravity straight down and the torque is 90 degrees. But as the object turns, the torque goes to 0. So gravity on this will not turn it. It will pull it down, but it won't turn it. And then lastly, we have these two pictures. The blue is the acceleration, which gives us a constant change of velocity in red. The blue, this one, acceleration is accelerating. So you get actually an increasing velocity. And these things do pop up once in a while, and I wanted to make sure that I just mentioned those. Anyways, your main job for today is to try to do not Sparky quiz, but all your MCQs, but specifically focusing on satellites for today. So have a great break, and I will see you soon.